Good day, welcome to Unit 5, Molecules. Okay, so we're going to be talking about a clump of atoms. So molecules are going to be a discrete clump of atoms connected by covalent bonds. They're different than the molecular solids in that the molecular solids was any old number of atoms, generally a gigantic amount, whereas molecules are going to be a very specific number of each type of atom actually arranged in a specific pattern. So they're not just their own clump, they're their own arrangement. So we think of them as their own individual entity, and that's kind of because they are. Now, with these guys, we need to talk about different types of chemical formulas. In the last unit, we talked about chemical formulas, specifically what we call an empirical formula. It's the smallest whole number ratio of atoms inside of our compound. Now, for things that form lattices, this makes perfect sense because the size of the lattice doesn't change the chemical. However, for things that are in molecules, the number of a specific type of atom does actually change what it is, because these are their own discrete clumps. One that's 2, 3, 4 times bigger is meaningfully different. Well, for this, we have the molecular formula. This is telling us not just really the ratio of atoms, it's actually telling us how many we have. So in this case, I have two examples. Both contain the same empirical formula. They're both 1 carbon for every 2 hydrogens for every 1 oxygen, but one of them that's it. 1 carbon, 2 hydrogens, and 1 oxygen. That's formaldehyde, the one on the bottom. And for the other one, it actually has 6 carbons, 12 hydrogens, and 6 oxygens, and that's glucose. And if you're familiar with those two chemicals, if glucose is sugar, formaldehyde is what they use to embalm things. Completely different molecules. Their arrangement of atoms is also completely different, and we'll get into that a little bit later, mostly in 1152. So first off, we've got new type of formula, the molecular formula. Now, when it comes to naming molecules, this can go down a really deep rabbit hole really quick, and we're going to jump down that rabbit hole in 1152. We're going to spend a whole unit naming what we call organic molecules, things containing carbon. However, we're going to start this off by naming relatively simple molecules, things that generally speaking only have 2 different types of elements, and they're just fairly discrete. The way we're going to name these is basically just by speaking their molecular formula. Now, a couple of caveats. We're not going to say P2Cl4. We're going to, for starters, give the elements names, not their symbols. So it'd be phosphorus and then chlor, and then whenever it's at the end, it's going to end in I, just like the last time. So phosphorus chloride. So just like you would an ionic compound. However, unlike an ionic compound where you can work out the ratio, you can't always work out the ratio for molecular compounds because they're going to be nothing but nonmetals. There's no cation or anion, even though we're going to name it kind of like there was. The other issue is, even if you know the ratio, that doesn't necessarily limit you to only one molecule, as you saw in the previous slide. So we need to give the actual numbers in the subscripts. Now, we're not just going to say phosphorus 2, chlorine 4, although in some respects that would make a lot of sense. Instead, what we're going to do is we're going to say those numbers as Greek prefixes. So we're going to say the Greek name for the number, and which you're all familiar with, C, math. It's the same as your polygons. And we're going to put them in front. So instead of saying P2, it's going to be diphosphorus. And instead of Cl4, it's going to be tetrachloride. Now, here's the quick catch that throws a lot of people. A lot of folks like to put quatra for 4, thinking to Spanish. We're doing Greek. Spanish evolves from Latin. So it's tetra, not quatra. Okay, straightforward. Here's a couple of quirks, though. Okay, first off, if the first element, the one that is going to be to the bottom left of the other one on the periodic table, and therefore will appear in the chemical formula first, the least electronegative one, if there's only one of them, you would think it would be named mono whatever it is. But we drop the mono. The mono only gets dropped if it's the first element, and the only prefix that gets dropped is the mono. So CO2 is carbon dioxide, not the somewhat more obvious monocarbon dioxide. Chemistry is a little bit like music. We don't say the same thing twice, and if I'm saying it, apparently there's at least one of them there. But once again, the only mono we drop is the first one. The next one turns into a tongue twister issue. Mostly mono, but a few of them. If you have an element name starting with an A or an O, and the one you usually have a problem with is oxygen, because the other ones that start with A and O tend not to be molecule-forming elements. So it's usually going to be oxygen. And the prefix ends with an A or an O, which is going to be, of course, mono. And then, of course, you got your tetra, your penta, your hexa, your hepta, most of them, truth be told, other than 2 and 3. If you've got this double vowel scenario where you have an A or an O and then another A and an O, it would become unpronounceable. So you would have something like carbon monoxide. Yeah, no. We drop the vowel from the prefix. So instead of being carbon monoxide, it's carbon monoxide. The mono just turns into mon. Same would go for all of your other ones. So for this reason, even though the simple rule would expect it to be monocarbon monoxide, it's carbon monoxide. As far as going back to the molecular formula, it's as easy as it sounds. You got your prefix, you know that's going to be the subscript for the first one. You got the name, once again, subscript for the next one, or the letter. So you just keep going through and bada boom, bada bang. We literally pronounce out the molecular formula. The only downside to dealing with naming molecules is that you get to memorize a little bit of Greek. So 1 through 10, usually a pretty good choice. Sometimes you get to do a little bit more, but for now, let's just learn our numbers 1 to 10 in Greek. Well, that's it for the basics, but we're going to jump in next time with what we call Lewis structures, because not only does the molecular formula matter, it also matters how we arrange those atoms. So we need to start actually being able to talk about the order in which those covalent bonds are put in. So see you next time for part 2, Lewis structures.